Welcome to my instructional video on the alternating series test. The alternating series test is this. For your alternating series, if a sub k is positive and decreasing, which it most likely will be on anything that you're given in class, the series converges if the absolute value of the a sub k, or non-alternating portion, approaches 0. You can tell this by taking the limit as k approaches infinity, as we will see in just a moment. So, for this example, we want to see if this alternating series converges. The first thing that we do is take the limit as k approaches infinity of a sub k. So, that would equal limit as k approaches infinity of this part. Basically, you just ignore the negative 1 to the k. So we have this, and it's very simple. This k to the 4th does not increase as quickly as this k to the 5th. So we'll have an infinity on the bottom and then a 1 on the top. Technically a 2, but it's close enough to 1. And 1 over infinity is close enough to 0. So this does approach 0. So therefore it converges by the alternating series test. At this point, we're done with this problem. All that it was asking was, does it converge? We say yes, it converges. Move on to the next problem. So for this next one, I'm going to show an example of an alternating series which will not converge. It will diverge, just so you can see what that would look like. So, just as in the last one, we start off by taking the limit as k approaches infinity of a sub k, which is limit as k approaches infinity. Oh, that is equals, not approaches. Anyway, of k squared plus 6k Okay, and since these k's are to the same power, it's going to be infinity over infinity, which means we need to use L'Hopital's a few times. Be 2k plus 6, the constants go away, minus 3, which again equals infinity over infinity. L'Hopital's again. Two over 8, and that is 1/4, which does not go to 0. Because it does not go to 0, it therefore diverges by the alternating series test. Again, this is the final step of this problem. If it diverges, there's nothing more that you can do. Move on to the next problem. So here's part 2, which is what I wanted to focus the most on in this video. It's what confuses most people about the alternating series test: conditional or absolute convergence. Now, if the question does not ask if it converges conditionally or absolutely, then by all means do not try and see if it converges conditionally or absolutely. You can just stop at the first step, converges or diverges. So, to begin it, we first have to see if it converges, which this one will, but let me show you that. K approaches infinity of the a sub k, which is ln of k over k to the 0.5. And we can see that this is going to approach 0, 1 over infinity, 0, because we know from like let me write it here. Bounded increases the slowest, and then we have logarithmic, and then we have algebraic, and then we have exponential, which increases the most. Here we have a log and an exponential, a log on top, exponential on bottom, so the exponent will increase the fastest, thus we have the infinity here at 0. So yes, this does converge by the alternating series test. That, however, is only the first part. I'm going to go ahead and make 2 blanks here, converges, and then this will be for conditionally or absolutely. So here's the conditional or absolute step. Here we have our original alternating series, and I've just transferred the answer blanks from the other page onto this one already. We know that as a whole it converges, and this is the blank for conditionally or absolutely. So to determine this, we again deal only with the a sub k portion of it, and what we want to know is if this a sub k portion will converge on its own or diverge, if this only converges due to the alternating -1 to the k part. So you can use any sort of test that you can think of to see if this part right here will converge. To me, this looks a lot like 1 over k to the 0.5, so I'm going to do a basic comparison test with that. 0.5, this is our a sub k, and then we have 1 over k to the 0.5, which is our b sub k, and we think that it's going to diverge because we can just see that this by the p series would diverge, and ln of k is bigger than 1, and we can go ahead and say that because b sub k is smaller than a sub k and b sub k diverges by the p series, that's not how you write p series, because this 0.5 is less than 1, that's how you do the p series. This a sub k part is going to diverge by the basic comparison test. And that is not the end, we would say. Therefore, that's not how you spell therefore. Now it looks like therefore. Anyway, therefore, as a whole, the original alternating series converges conditionally. Conditionally. So if you get a divergence, it's going to be conditional. If you get a convergence, then it's going to be absolute. At this point, the problem is finished. Bear in mind, you don't have to check for conditional or absolute on every alternating series test or alternating series problem. I want to emphasize that. And if you get diverge in the first blank as the checking to see if it goes to 0 or not, then you can just stop there because it can't diverge conditionally or absolutely. That doesn't make any sense. So at that point you would be done with the problem, and that's about it. Thank you for watching. This has been a Stephanie Dykes production.